Hi guys, today I'll continue to discuss the scoop marks at the unfinished obelisk and other areas of the granite quarry at Aswan, Egypt. These perplexing excavating markings, the so-called scoop marks, appear as if the granite was softened like butter and scooped out with a shovel. In my last video, I explained why softening granite to a ductile state using either frequencies or heat for quarry purposes was not practical. Also, despite the prevalence of scoop marks at Aswan, there is no scooped granite nearby. This means although the scoop marks might look like the stone had been softened then scooped, it most likely had been broken down by a tool that left scoop-shaped trails. I compared the vertical scoop marks at the unfinished obelisk with the various vertical marks found in modern quarries, as they are all excavating markings generated during a process separating stone blocks from surrounding rock. The scoop marks are distinct from chisel, teeth, saw, or drill marks. The quarried facades are not as smooth or consistent as the modern circular drilled surfaces, and the scooped rock faces can be uneven, patchy, and bumpy. Plus, the scoop marks can curve and change angles during the excavation process. These characteristics have me pondering that the drilling which left scoop trails was neither mechanical nor precise. As advanced as it was, the tool was used as the first step to rough shaping and separating the stone blocks from surrounding bedrock, but not for more precise cutting and detailing. For these reasons, I propose that the scoop marks might have been created through a thermal jet torch, which directs a high-temperature flame against the granite, causing the surface to flake off due to rapid temperature changes and thermal stresses. This method is highly effective for large-scale channeling on hard, quartz-containing rocks, such as granite and quartzite, and is still used in quarries today. I received many interesting comments. Some asked about the possible fuel, torch nozzle, and the mechanism of the flame jet torch. Some suggested different excavating methods like water jets or the chemical Natron theory. The Natron theory posited that ancient Egyptians used the molten natron to weaken granite through a chemical process, and then pounded dolomite balls on the weakened granite to create scoop marks, and thereby excavated the unfinished obelisk. In this video, I'll respond to these questions and explore the following. Can water jets or the natron chemical method create scoop marks? What kind of cutting marks and surfaces these two methods actually form? Then I'll show you photos and footage of a high-tech excavating tool, which in my opinion generates the closest scoop-like marks to the ones at the Aswan quarry. And if this was how the unfinished obelisk was carved, then the scoop marks were not the work of ancient Egyptians, but a lost civilization with advanced technology. Let's start with water jets and see if they could create scoop marks. The unfinished obelisk is a massive piece of stone, measuring 42 meters or 138 feet in length. On and around it, there are indented square scoop marks, looking like a strange chessboard. These indents have similar dimensions of 40 by 40 centimeters. The vertical scoop marks are also 40 centimeters wide. This implies that the cutting surface of the tools utilized to excavate the unfinished obelisk is about 40 centimeters wide. Water jets are mostly used for precise, smaller-scale work. The nozzle diameters typically range from 0.1 mm to 1.5 mm, or 0.004 to 0.06 inch, as smaller nozzles offer higher pressure and greater precision for intricate cuts. Larger nozzle diameters allow for higher water and abrasive flow rates, resulting in faster cutting speeds but less precision. For high-speed, bulk material cutting, large nozzles range from 2 mm to 6.35 mm, which is 0.08 to 0.25 inch, which is still too narrow, not even 2% of the 40 cm wide scoop marks. The water jet streams are designed to be very narrow for a good reason. A much wider nozzle, say 10 centimeters in diameter, would disperse the water jet stream and abrasive particles too broadly to achieve the precision and cutting power required for effective cutting. While precise, Waterjet cutting can be slower than some other methods, especially for large volumes of a material. Waterjets also require a significant amount of water, which might be a concern in water-scarce areas. The waterjet cut faces are typically straight and smooth. Rougher cuts will exhibit more prominent vertical or diagonal striations, especially at bottom of the cut faces. This is different from the soft, wavy, and bumpy texture observed on the scoop marks. Sometimes, the jets can create small erosion grooves on rock which resemble the vertical bands of the unfinished obelisk. But such miniature grooves cannot be scaled up to the scoop mark size. When water jets are employed in quarrying operations to separate blocks of stone from the bedrock, in softer rocks like sandstone quarries, a pure water jet is often used to disintegrate the material. Harder rocks like Aswan granite will require abrasive water jets, which incorporate abrasive particles, higher pressures, or longer cutting times to achieve the same depth as softer rocks like limestone or marble. Speaking of cutting depth, the vertical continuous scoop marks at the obelisk are about 4 meters long. Abrasive water jets can cut much deeper than pure water jets and are able to cut granite up to 12 inches per pass. Since the unfinished obelisk is 4 meters, 13 feet thick, this means with abrasive water jets, one would need to cut vertically down 13 times or passes at one location to reach to the bottom of the obelisk trench. Multiple water jet cutting passes on thick granite will almost always leave visible signs, if not polished or finished afterwards. Each pass may leave a slight ridge or groove where material was removed. These may look like horizontal lines or terraces. Different passes can also cause striations with slightly varying angles or patterns. But the Aswan vertical scoop marks do not display these features. This means water jets are unlikely to be the answer to the big scoop marks, as they do not have a large enough diameter to produce the 40-centimeter wide bands. They cannot cut deep enough without leaving many horizontal seams, and their cut faces and striations are substantially different from the scoop marks. On top of that, for a big project the size of the unfinished obelisk, water jets are not as efficient as other cutting tools. Then what about a chemical method, like the Natron theory? Can that explain the scoop marks? The Natron theory is proposed by Marcel Foudy, that ancient Egyptians burnt natron, aka sodium carbonate, on granite to get molten natron to react with the quartz in granite, which produced water glass, effectively etching and weakening the rock. Once the granite was weakened or even pulverized, then ancient workers used stone balls to pound and excavate the obelisk. I found several problems with this theory. The first is that the natron rock softening method would significantly change the rock colors and appearance. Here is a photo posted by Mr. Foudy where we can see visible color and appearance changes, while the granite of Aswan Quarry shows consistent color at all scooped areas. When a laboratory chemical reacts with the minerals in a rock, that irreversible process would typically change the rock's composition and potentially its color. Even if the discolored, weakened granite was removed with dolerite balls as claimed, there should be left some traces of the chemical reaction, especially at the edges between the treated and untreated granite. Why are there no scoop mark edges at Aswan showing any signs of chemical erosion or the dissolution of quartz? Foudy published footage presenting how the natron was melted to etch granite. The whitish cube is natron. So, a large amount of natron was needed for the reaction. Later, the weakened granite surface got stone ball pounding and disintegrated to small pieces. It is hard to tell how thick of a layer of granite was removed. Granite is very dense, hard, and has low porosity, meaning it's highly resistant to most chemical penetration. Strong acids like hydrochloric and hydrofluoric acids under favorable conditions can penetrate 1 to 3 mm or 0.04 to 0.12 inch. Some sealers can penetrate up to 10 mm, less than 0.4 inch. How deep can the molten natron penetrate and react with the quartz in granite? The penetration capability would impact the effectiveness of the natron method. Here is later footage showing an alleged scoop mark produced with natron. Foti emphasized that a lot of charcoal was utilized just to create a minimal-sized depression on the granite surface. If the natron theory requires a lot of charcoal and natron and still just penetrate very shallowly into granite to form a tiny and superficial dent, then that signifies this quarry method is ineffective and not cost-efficient, hence not practical. Egypt has been a desert with scarce natural woodlands for 5,000 years. Charcoal had to be made from limited timber resources. Would dynastic workers be able to afford to burn so much of their limited charcoal or wood plus natron to just barely dent the Aswan granite? Even if we assume people had a plentiful supply of charcoal and natron in ancient times, would they choose such an inefficient quarry technique? And why limit the molten natron trading areas to individual 40 by 40 centimeter squares or 40 centimeter wide bands? Chemical treatment should not have such strict size limitation. If the goal was to excavate a trench to separate the obelisk from surrounding bedrock, then why bother pounding out these neat vertical bands on the non-obelisk side of the trench, the curved corners, and the ridged trench bottom? Such procedures are completely unnecessary. More importantly, the natron scoop mark posted by Foti does not resemble the real deal. Putting the size, shape, edge, and rock surface differences aside, the natron chemical reaction left white, foamy-looking solid lumps. They are water glass or sodium silicate. To remove this messy sodium silicate, one can either dissolve it using specific chemicals like strong alkalis or strong acids, which could then change the stone appearance, or physically remove it by scraping or chipping. If the natron method was practiced at Aswan, then there ought to be some white water glass residue left near the scoop marks, no matter how careful the scraping and chipping work was done, since the dissolved quartz would leave cavities in granite, which would naturally be filled with the production of the chemical reaction, this white stuff. Even supposing the ancients had some miraculous ways to remove the white water glass without a trace, they should not have needed to remove the white lumps on the non-obelisk side of the trench. But there is zero sodium silicate on site. All of this is pointing to how unrealistic the natron theory is. By the way, the problems we encounter when trying to explain the scoop marks with the natron theory can be expected with other chemical excavation proposals as well. In modern quarries, chemicals can be used to weaken or break down rocks, such as expanding grout to be poured into the pre-drilled holes in rock. But this would not create scoop marks. In some cases, specific acids can be used to dissolve certain types of rocks or minerals, but this is a slow process and used particularly when the rock is ground to a fine powder, but not in dimensional stone extraction. So, neither water jets nor chemicals are a plausible explanation for the formation of the scoop marks. I mentioned at the beginning, the consistent width of the scoop marks indicates that the tool had a defined cutting face. The scoop marks' relatively smooth yet slightly uneven and bumpy finishes and lack of sharp striations or drill marks have me deduce that the tool was not mechanical or precise. If the scoop mark creation did not rely on mechanical forces or chemical reactions, then there is one logical choice left: heat. Flame drilling is highly efficient for creating holes and cavities in quartz-rich hard rocks, such as granite, that are difficult to drill using traditional methods. I hypothesize the scoop marks were made through a high-temperature flame torch with designated heads and nozzles. Now, I'm going to show you the thermal rock excavating machine, which produces trails that do in fact resemble the Aswan scoop marks. This is a plasma spallation machine invented by EarthGrid, a Bay Area tunnel boring technology and infrastructure development company. In 2023, EarthGrid announced developing the world's first plasma tunnel boring technology, which has the potential to revolutionize tunneling, trenching, and excavation. Their machines employ high-power plasma torches that can reach 48,600 degrees Fahrenheit or 27,000 degrees Celsius to vaporize and break down rock into small fragments, and are able to bore deeply, approximately 10 to 100 feet, 3 to 30 meters below the surface. This company has tested single-headed torch, two-torch, and three-torch models. The plasma plumes bore quickly via spallation and vaporization, allowing excavations with greater precision, speed, and depth. What I'm showing here is a tryout with a two-torch system on a granite block. The torches left a sizable depression with defined outlines on top and soft and curved lower edges, and two scoop-like indents. Perhaps the shape and sharpness of the boring edge relate to the torch's angle and placement. The size, depth, shape, and cut edges are not too different from the Aswan scoop marks. Some scoop marks on the obelisk are rather shallow and obscure compared to the ones on surrounding rock. They might have been smoothed out with flame torch surface treatment after the initial excavation, which is also practiced today. The chessboard scoop marks appear to be squares, though their indented bottoms are actually roundish, in a way similar to a half-ball-shaped baking tray. When the torches rapidly vaporize and spall the rock, each torch creates a circular, curved basin-shaped dent, as if the rock was scooped out like ice cream. In between these soft-looking round depressions are leftover stone ridges. Could the strange Aswan-dented squares with roundish basin bottoms have been generated with multiple-headed, high-powered torches? When plasma torches form grids of roundish holes in rock, the leftover stone ridges between these holes might look like square shapes as the chessboard scoop marks. The unfinished obelisk was separated from the surrounding rock through digging an all-around trench. The trench is covered with vertical excavation bands, and these scoop marks curve at the bottom. Here is footage from June of 2025 at the Sierra Granite Quarry with an earth-grade two-torch system drilling down to create a channel on the bedrock. The plasma torches successfully cut through granite and made a channel with efficiency. Check out the finished product. Using the people standing by the channel as reference or perspective, we can tell the width of the channel is not too far from 40 centimeters. The channel opening is not perfectly straight, but somewhat deviated, like the trench surrounds the unfinished obelisk. They both are accurate enough, yet not as precise as line drilling or saw cutting. The top of the Sierra granite channel is rounded with curvatures, like this part of the obelisk trench. The Sierra channel wall has slanted vertical patterns. Each vertical stripe ends at the bottom of the channel with a curved corner. These characteristics resemble the vertical scoop marks of the obelisk trench and the rigid trench bottom with curved corners. It's exciting to see that the excavating markings from a plasma torch system share quite a few common features and scale with the scoop marks of the Aswan Quarry, isn't it? These machines are named Rapid Burrowing Robot, RBR, and they can run on electricity. Other flame jet torches might use a variety of fuel gases such as propane or acetylene, combined with oxygen to create the high-temperature flame necessary to cause rock spallation. The flame torches for stone cutting came out in the 1950s. The plasma rock boring system was invented in recent years. This type of high-tech equipment was obviously not available in ancient Egypt. If the scoop marks were really created by plasma torches, as evidence suggests, then the Aswan scoop marks could not be the work of ancient Egyptians, and the unfinished obelisk had to be quarried by an earlier civilization, a sophisticated one that possessed plasma technology and powerful cranes to transport the obelisk. In prior videos, I postulated that some ancient megalithic sites might be remnants of this lost advanced civilization. I also proposed this civilization's potential timeline and the possible causes which eventually led to its collapse. You can find the video links below in the description section. In summary, my hypothesis on the intriguing scoop marks of the Aswan Quarry is that they were likely the product of certain high-temperature plasma torches which can be configured with multiple heads. The markings are the result of thermal spallation and vaporization, not due to waterjets, chemical reactions, diamond drills, or pounding dolorite balls. What do you think? If you have any insights, please leave me a comment. If you like my video, please subscribe to my channel and share with others. You can also support me on Patreon, which is a monthly charge, or on Buy Me a Coffee. I appreciate your support. This is Curious Being. I'm Tina. Thanks for watching and see you next time.